So welcome everyone in problem solving and outlining session number 10 of the course titled ME91 Production Technology Theory and Practice. So this is the 10th session, and first of all we will solve the assignment for week number 9. This is the assignment for week number 9, and this is the first question for it. For high powered AC machines, the drive system normally used is, okay, everybody knows that we are using hydraulic machine because of the its nature actually. It is give high power. So, in my previous assignment also I showed this fact that it is used for small size and high power machine. Okay. So hydraulic machines are used for high power applications. So what is high power? You are using hydraulic machines. It is B is the correct answer. Okay. So in stepper motor, the shaft speed is steps per second is equal to. Okay. If you go to the slides properly and assignments also, so incoming frequency is impulse and second is your correct answer. So right, that number of input pulses are not actually correct answer in case of stepper motor. So incoming frequency only decides the shaft speed. Okay, so A will be your correct answer. Straight cut CNC control can use for multiple axis control simultaneously. One axis motion at time control for machine. Point to point control, both point to point control and one axis motion at time. Okay, so we are using just a straight cut. So for that you don't need a multiple axis control simultaneously. Okay, you can only go with first. It's this only one point to point it is required both at one axis, and okay, this is not required. As this is not required, this will also not required. So and this will be required. Okay, so both can be used. So one is wrong and fourth is wrong. Means your 2, 3 and 5. So 2, 3 and 5 will be correct answer. So your D will be the correct answer. Okay. Question 4, for a stepper motor, CNC based control loop that is usually, okay, you know, for stepper motor you don't go for closed. So we go for open part. Okay, this is not used. This are as you are not using feedback at all. So open loop would be your correct answer. Okay. It is a DC motor is different and your stepper motor is different. So okay, for stepper motor we go for a control loop. Okay. Open loop control. Adaptive control system has a significant effect on in-process time. Okay, in my assignment also show you the in-process time is process consume is time consumed during production of the machine energy. So if you are using adaptive control, in-process time is significantly reduced. Okay, so in-process time has also effect on adaptive control. Changing the system parameters by the adaptive control system in the modification. Okay, which parameter actually using the changing the 12 parameters here. So we are using modification function. Identification we are not using decision function, we are using is for decision. Identification we know for identification I mentioned there, and modification is only used to changing the for changing part we are using this modification part. Okay, so only this will be your correct answer. Okay, so the tool motion which has been executed by CNC part program by the block. Okay, so this is your just number G03 means you are knowing this going to be circular and which counterclockwise. And this XY is no as per the options. Okay, so you know this G03 is only main factor here. What it reduced circular interpolation. I told you go to the tables and the everything that you have from slides also and tables also you can go from standard literature. So only you will get that G03 is related to circular interpolation. And again counterclockwise. Okay, that is more important. In CNC operation, the tool is at 5-4 at the beginning and operation will move the tool from 5 to 4 to 7 to 2 along the circular path. The center is 5 to 2. The CNC part program block is given now. Here I told you how you can solve such problem. Okay, just draw the axis here and where is your like 1 2 input and we will got that how what will you get. Okay, actually 1 2 3 4 1 2 3 4 5 6 7 8. Okay, and this will be your 6. Okay, so what is your first point? 5 4. Okay, so 5 is your x-axis and this will be your so this will be 5 4 and second is 7 2. Okay, 7 and your 2. Okay, so 7 and 8. Okay, so how we are going from this to this? Okay, this is like clockwise. So this code will be P02. Okay, only this. So this is only correct answer because I show you here only you can use this code and only this at G02. Okay, so this will be your only correct answer. You can go to one person. Okay, and again this G7 is your endpoints and I is the central points. Okay, so those what will matter was only G02 is the matter of concern. Okay, how you can find out just by plotting on simple on your like simple on your paper like you can draw a paper like this and you can simply solve. I told you this part is my assignment also. Okay, previous assignment. Okay, assignment. So do this and solve your answer. Okay, so this is your answer. I showed you how it will be your answer. Okay. This is the ninth question in the CNC part program. Block 1003 S1000 stands for. Okay, so you know from the standard tables and the standard literature that you have. Okay, you can refer the standard tables or books. Okay, from what you will get this M03 stand for spindle on clockwise. Okay, and if we are going for his counterclockwise, it is actually M04, not M03. Okay, so as they are mentioning M03 means it is clockwise only, and the speed that is the speed that they are giving, which is the RPM. So that speed RPM is 2000. Okay. Speed, it is actually the speed in rotation and RPM. Okay, speed in RPM is this. So this will be your S. That is for speed in RPM. What is the value of it? It's 2000. Okay, so 2000 RPM will be your speed. Okay, this will be the correct answer. Okay, this off is on clock counter I told you, and this is coolant is again for coolant you I told you it is M08. So it is wrong. What you are having here M03. So only this will be your correct answer. Okay. So question 10. Adaptive control can be used when the source of variability are not many, in process time consuming less, the production is mass production only. Okay, so these are simply wrong here. Okay, so this is only correct. So these are wrong, and this is only the correct answer if you go through the slides properly. Production of is only mass production. Those are actually wrong terms here. Okay, this is correct. Okay, and this is actually opposite to each other. See, so this part is only correct, so this part is wrong, this part is wrong. Okay, this is wrong. So only this part is correct answer. If you go to the problem to the slides, so this is only your correct answer. Okay. Okay, this is the end of the 10th question for the assignment. So it is very simple. You can out about marks here. And right now we are going from practice problem sets for a week. I told you practice problem sets for week 10. Okay, so here we go. This will be your first question. So you can solve. After that I will solve. Okay, you can take your time to solve this question. Okay, so it is simple. You can solve it very easily. The meteorology science of light. So it's wrong. Sound wrong. Energy wrong. So what is it? Measurement of okay. It is not a meteorology science of not energy, not sound, not light, only for measurements. Okay. So these all are wrong. So only measurement is correct answer. So your D will be your correct answer for meteorology. So this will be your second question. The degree to which the measured value agrees with the true value of a quality of interest is called as. Okay. You can take your time and solve it. Okay, so the degree to which its measured value agrees with the true value of a quantity of interest is called as, it is not a measurement obviously. Accuracy is your correct answer. You have to go through the slides properly. The precision is different, none of the way wrong, it is wrong. So only this is your correct answer. Okay. Accuracy. See, accuracy is your correct answer. So your third question. The degree of repeatability in the measurement process. So here you can read the answer which is precision. Okay. Yes, I already told you answer in previous part. Okay, so previous part is what? To get a degree to which measure quantity value is the true value of the quantity. Okay, true value of the quantity. You can see the true value of the quantity. It's called accuracy. And right now, repeatability. It is called as precision. Okay. Accuracy is not measurement is not none of the above. Okay, so precision only correct answer. And you know what about accuracy is coming here. So this will be a precision. And it is actually the degree of repeatability is your precision. Okay. So precision is only a correct answer. Okay. In case of metrology, this is the correct answer. So, good precision means that random errors in the measurement produced are. Okay, so we asked about the precision previously. Right now we are going some insights at what actually precision means here. Okay, so that is here, what you are asking here. This is the fourth question for you. Good precision means that random errors in the measurement produced are. And maximize the minimize you can say none of the above. You can go to the slides, take your time to solve. Okay, so what is the answer here? Okay, you don't need to maximize the so maximize is wrong. Dimension is against the wrong. None of the above is wrong. Okay. So that left with you will only need to minimize it. Okay. So goal precision means measurement process are a random error so must be minimized. Okay. For a good precision. Okay. So the minimize is only a correct answer. But you never want to include maximize. Okay. So this maximize can be taken option. Dimension is not one. Okay. So this minimize is only the correct option that you have. So this is the fifth question. Which of the following is not conventional measuring instruments? So these are the conventional and which out of it is not conventional? That is the question that we ask here. Okay. If you go on through the slides, you definitely read that. This is the conventional. Okay, this is so this conventional what you're asking. So this is conventional. Comparative is again a conventional. Fixed gauges is again a conventional, and angular measurement is again a conventional. So what of them is not known? Okay, so none of the above is your correct answer for not. Okay, so not is none actually. None of the above are not correct. So everyone are conventional. Okay, so none of the above is your answer. Okay, this is none of the above will be your correct answer. Okay. This is the sixth question. Standard against which other dimension measurement and areas are compared are called as. So what are the standards that were used to calibrate other things? Okay, so with this fixed gauges, comparative instrument, none of the above. So definitely we have answer here. So none of them was wrong. You could get from this precision gauge blocks. If you got the slides properly, you will get answer is precision gauge blocks. Okay, so this is your answer, precision gauge blocks. Rest of the thing that you down. Okay, so is fixed and all stuff is not given. None of those are the ground, so only this is the correct answer, precision gauge block. Okay, you can go through slides to get this answer. What is true in case of precision gauge block? Yeah, in previous question we asked that what it is used for. Right now we are asking that what is the what is true in case of that. Okay, so this will keep it slightly here. Okay, so this is your question. Okay, so what is true in case of that? Okay, so this is the question. What is true in case of precision field? Now, so this we have to find out. You can take your own time to solve them, but the answer. Okay. Okay, so usually when a rectangular blocks, okay, it's the correct answer actually. Surface are finished to be damaged in accurate and panel to positive million of inches and polished representation that's have been correct. Precision gauge blocks are available in certain standard later contain a variety of different styles. Okay. So all of them are actually correct. We can go through the slides or even standard literature if you can go through. You will get this is actually concept. Okay. So in the standard books you can refer and look for or literature you will have you can find all of these are correct. Okay. So all of the above will be your correct answer. Okay. All of the above will be your correct answer. Choose the it which out of the following are geometric form of measurements. You can go through slides if you want. Okay, so what are the actual answers? So which out of the following are geometric form of measurements? It roundness, okay. Geometric form of roundness is the correct answer. Straightness, geometric form, cylindricity, and flatness. Okay, all of them are actually your geometric forms. Okay, all of these. So all of the above is the correct answer. As all of them are actually your geometric forms. Okay, so all of the above is the correct answer. So yes, all of the above as all of them are geometric forms of measurement. So all of them is correct answer. These are and so I mentioned previous question. So which out of the following are geometric relationships? Okay, right. Previously we have forms. Right now we are asking for relationships. So which out of them are actually relationships? Okay, so you go out of part is a perpendicular parallel concentric turnout or all of the above. So this is the point you have. So, okay, so we can go through slides. Okay, so is like it is a specific only one or all of the above? So you can take two of them are there, they are all of this answer. Mostly all of the above is the answer. Okay, so you get the answer that is parallel also. Parallel is actually geometric relationship. Okay, lines are parallel. Perpendicular is again geometric relationship. So coeccentric and runout is actually so coeccentric is not like that. Coeccentric is no, so exactly at the this center is exactly the same. Exactly we have the center and okay, so coeccentric is always part of it. And perpendicular coeccentric we have and runout. Okay, so this is also part of the geometric relationship. Okay, this runout also geometry. So these all are correct answers actually. Okay. Also, in case of geometric relationships, if the runout also comes with the geometric relationship. If you go to the slides, okay, this concept is always there. So all of the above is the correct answer. Okay. As everything mentioned here is actually geometric relationship. Okay, so all of the above is the correct answer. Strength question: which measuring instruments are designed to mechanically magnify the deviation to permit observation? Okay, so like mechanically magnify the deviation to permit observation. So which is that instrument we use for that? That is the question. Okay. You can take your time with this slide. You will get the answer. Okay. If we go to the slides, definitely get the answer. The gauge blocks is not used for magnify. Okay. So sidebar is different. Calipers and calipers are different. It is not used for magnify the elevation. Okay. So for magnifying the elevation, these glasses are not used. So what is used? Only dial gauge can be used. Okay. A dial gauge is actually used. So dial gauge can be used. Okay. So permit observation to dial gauge is only the correct answer. Okay. So this only can permit for mechanical amplifier to permit observation. So dial gauge is correct answer. Okay. So dial gauge. Dial gauge is okay. Is dash dash is a 2D tolerance that controls how close the cross section of a cylinder cone is to a mathematically perfect circle. You can go to slides if you want. So Fourier tolerance that controls how close the cross section of cylinder, sphere or cone to mathematical perspective. Okay, so you call the slide to make great answer. Okay, so roundness is a correct answer. Because cylindricity is different. Porosity, constitution again, these are actually different parts. So so only the at how closely contribution to the cylinder sphere, okay, that will be perfect circle, okay. Only the roundness will tell you because there are also in sphere and cone, okay. So roundness will tell you how accurately perfect circle is. This roundness is the correct answer, okay. So well, the 3D version of roundness it axis how closely an object comes to a perfect cylinder, meaning that it is not only round but also straight along its axis. Okay, so you know, even in this case we are mentioning. Perfect cylinder means what? It is round as porosity, concentricity, or cylindricity. That's the question. In that question, you also verify the answer. Okay, so you can take time to solve. As I already told you the answer, okay, so we go through the slides properly. Cylindricity is the correct answer. We have to already the quantitative mention cylindricity. So cylindricity is the correct answer. Okay. So roundness is not correct. So this is the correct answer. Cylindricity is the tolerance for how close the axis of one cylinder is to another. Okay. It is about axis of one another to the other. Axis of one cylinder to the other. So you know cylindricity are already gone. So we will do this, that is coercivity and concentricity. So out of two, we will go to solve the answer. Okay. Okay, so if you go to the sites, you might get the answer. So it's coaxiality. Okay, I mentioned all that also. I mentioned the axis means it is actually your coaxiality is your vector. Okay, so these are now concentrated is not okay. So we are mentioning your axis. So this coaxiality is only correct answer. Okay, this part. And now question 14. The special case of coaxiality occurs when a part is measured at a same cross-section plane component the ideal related to each other on a hollow shaft or tube. Okay, so right now we are mentioning ID and OD. So Here we go with something with radius. It's called as concentricity. Okay, so we have to order the answer here also. Okay, so this part are actually wrong. So always we left with concentricity is only the correct answer. Okay, so rather than changing your IDs and use internal diameter, so outer diameter, outer diameter, inter diameter, okay, inter diameter, outer external diameter, outer diameter. So this actually concentrating is the correct answer. And ID audio and message. So this is a percentage of the correct answer. Just a question, take the entire part into consideration and all variation across the entire surface must follow the specific tolerance. It's called as what? Like run out, total run out, question is there, falls anything. So this part of the this not a this one. Question is due to run out of the total. Okay. So you can take your answer to solve this question. So if you want to the answer, okay, you might got the answer that is total run out is the actual answer. Okay. Okay, so total run out is actually answer is also taking entire part into consideration and all variation across the entire surface must fall within a specific tolerance. Okay. So your entire section and means okay, so entire surface and all the entire part. Okay, so this your entire network taking is taken to the run out into consideration. Okay, so the run out is not answer. So the run out is only answer. Why you are taking because you're taking the entire part. Okay, so that is what. So this is the entire. 16th question. The allowable deviation is called as what? The run out, total run out, tolerance of fit. That's the question. Okay. Okay, so if you go to the slides, you will get the answer. Is actually tolerance. Okay, tolerance is the correct answer. So turn out always know it is wrong answer. So the run out is completely different. Fit is completely different. So only so allowable deviation is actually only your tolerance. Okay, is the correct answer. Okay, so this tolerance is the correct answer. This tolerance, as it is mentioned, deviation. Okay. You can go with that for it. Okay. So what is true in case of tolerance now? This is the question. So we have to do tolerance. Right now, what is true in case of the tolerance part? Okay, if you go through the slides, you may get total amount by which the specific dimensions is permitted to vary. Okay, this is tolerance. Okay, the actual. Okay, this is correct actually. Okay, this part is correct. This option is correct. Means for tolerance, we are checking here. Okay, the difference between maximum and minimum limits. Okay, that's again correct. Used to define limits of allowed variation. Okay, so these all actually satisfy the cases for tolerance. Okay, so all of the above will be correct answer. Okay, yes, all of the above will be correct answer. Okay. So why tolerance is necessary? Okay, so why it is necessary now? You can go to slides to check the answer. Okay. So why here we have mentioned why it is necessary the tolerance part. So why tolerance is necessary? It, it is impossible to manufacture a part of component of exact size or geometry. Acceptable degree of variation must be applied. Okay, so this part is correct. Okay, you know this part means this is correct answer. Okay. A large variation may affect the functionality of the part. Okay, so yeah, for tolerance, though it is not correct, it is not easy to manufacture it, and some acceptable degree of variation must be given. Okay, so this is correct part. Okay, and large variation affect the functionality of the part. Okay, that is again correct. Small variation may affect the economy of the part. Okay, yeah, that is again a correct option because it is a concept of cost involved when you are going for smaller variation tolerance. Okay, so this is again a correct part in case of tolerances. So all of those will be correct answer. Okay, okay. Means all of the above is correct answer. Written question: why is or are the problems with smaller tolerances? Yeah, we are mentioning cost again. Okay, so here also there is cost may come into the picture. Okay, the small cost, that how much cost should we have, what is the economy of the part, that will have a cost. Okay, so this is again important, and it is also coming here. Okay, means here also discount cost increase. Okay, so what are the problems that were asking? So this part then coming here. So this is what we are asking. So problem specific. What are the problems in order? We go through slides if you want to take the answer. Okay. If we go to the slides correctly, so cost increase due to smaller tolerances, cost increase is correct. Required special measures to manufacture in case of small tolerances. Okay. So in case of small tolerances, so this is correct. And this part is again correct. Required greater inspection and call for realization of part of it. So this is also correct. Okay. So all of the above will be correct answer. Okay. So as all of the options are correct. Okay. Here. So these all are correct. So all of the above is a correct answer. Okay. This all satisfies the condition for small tolerances. So this is the answer question. Which we don't have part of it. There is a straight line corresponding to a basic size. Okay, so zero line is the actual correct answer. Okay, means a straight line corresponding to basic size. So what is called a zero line. So the zero line is correct answer for your 19th question. Okay, this is the basic size. So that line is called as is zero line. So this is so correct answer this question. Okay, electrons developed by convention to design all external features of a part, including those which are not cylindrical. What is the main point to highlight it? External features. So after that you can get answer. Okay? So if you go on to the slides, I already told you the Excel is an important feature. So your answer is shaft. Okay. The other is already gone. So what is the point here? The shaft is your correct answer. Okay. So the shaft is your correct answer. Okay. Is the difference between the basic dimensions of the meeting part? So tolerance allowance whole shaft. So the whole shaft is a different concept. So this one already. So tolerance and allowance is the answer. So you will fit between these two parts. Okay. Which is the difference between the basic dimensions of the meeting part. So if you go on to the answer, so tolerance is again it is different concept. What left with only allowance? So the correct answer allowance. Okay. Is called basic dimension. The difference between the basic dimensions of meeting part is the allowance. So your next question 22. Is the size with reference to which the limit of the size are fixed? What is that? So to 19 questions actually that about basic lines. So what is that size? The limit of size are fixed. The size with which the limit of size are being fixed. So what is that size? It's called as. So please answer. So what is called as? What's the question? You can go through slides if you want to sit and so on. You go to slides and you can get answer. So if you go through the slide, okay, what is the answer you got? I told you actually that about the question number 19. Okay, so baseline. So give your base size. Okay, so which it is fixed is base size. Okay, I told you the size which limit of the side is fixed. So it is actually basic size. So basic size is your correct answer. Okay, it is the algebraic difference between the maximum size and the basic size. What is it? The algebraic size is very good difference between maximum size and basic size. Okay. We know that the actual size is different. Okay, the basic size you have. So actual size is not the correct answer. Tolerance zone is a different concept. So actual you could find out between is per deviation and no deviation. And again, the maximum is important term actually. Okay. So this maximum part is important. So you can decide what is either it is upper or lower deviation. If you got a point at maximum and the difference, so it is very easy that you can get the upper deviation. So I told you given the all possible things that is possible. Okay. So upper deviation is the correct answer. Lower deviation of a shaft is represented by which symbol? Lower deviation of a shaft. Lower deviation of shaft. You can refer the slides okay, for that. Okay, so if you go to slides, you definitely get the answer. So this is the correct answer. Okay, this E and I. So both the slides will be that part. So this is the correct answer. Again, the same kind of question, but upward deviation for whole now. You can go to that and you can solve the same basis. Okay, that take time to solve this question. Okay. In both the slides, if you wanted, take the answer. Okay. So what answer you get? Okay, so this will be correct answer. Okay. So refer to slides. Okay, it will be there in slides. Okay, so mention. So this is the correct answer. Okay. So the 26 dimensions of a part is allowed to vary on both sides. The basic size that is the reverse tolerance beyond the other side of the basic size. Okay. So here what important part to be highlight. Okay, vary on both the sides. Both is the important part here. Okay? Vary on the both the sides. Okay, and from that we can get the answers. Both the side is here important part. Okay? So up to the both side is important part. and that is either on the side, so either on the basic side. So you get the answer from Phelps. Okay, so I told you that vary on both sides. Okay, so unilateral can be your answer. Bilateral is not, none of the above is not. So vary on both sides means bilateral will be your answer. Okay, this bilateral will be your answer. As I told you, both is mentioned here, so this bilateral will be your answer. Okay, I told you, focus on both, so bilateral will be your answer. What is the true in case of clearance fit? Now we are moving to fits. Okay, so what is true in case of clearance fits now? You can refer the slides also. Okay, just better. You can go to slide and right answer. Okay, take the answer. You can take your own time to solve. So what is true in case of clearance fit? You got the answer. And air space or clearance exists. Okay, that's correct actually. Space exists. Fit gives good joy is incorrect. Has positive allowance Yes, because we are looking for clearance. Correct. Allow rotation of sliding between moving parts. Okay, it is also correct. So the clearance air is there to join positive allowance and rotating sliding between making parts. So all of correct means all of the above is the correct option. Okay. So all of the above is the correct option. Okay, so we go about some types of clearance group now. Okay. So what out of this part are actually types of clearance. So, like moves running feet, slide feet, or all of the above slide. Okay. You go through slides and retain the answer. Okay. Like which of these are actually one are there or many are there. So it's straightforward. All of them will be answered. We go through slides, rows, Twitter, and slide which are an actual part of. Because rows, learning, slide, what is actually implied? Is everything actually implied clearance? That's it. So what are the types? That it's that simple. Okay. So different point to see the simple. So I told you already that those running slide allow the part of clearance. Okay, yes, you can see these all are actually it symbols clearance. Okay, so all of them will be correct option. Okay, this is the correct answer. All of them. So what is the communication with interference speed now? Let now go for interference speed. You know what is interference speed? How exactly about the clearance? So if you see the of all the options, the negative difference between diameter of the hole and the shaft. Okay, so this is the correct. Okay. There is a negative difference okay, between the diameter of hole and the shaft. Okay. There is a negative difference. Okay, so what actually here meaning the shaft is bigger than hole. So there is a negative difference. But the negative means the shaft is bigger. Shaft is bigger than your hole. Okay. Diameter of shaft is always larger than hole of diameter. Okay. So this negative difference is always correct and then this is bigger means your the shaft diameter is always larger. Okay. So these all are interconnected. Okay. So these all both of them are correct. Okay. Usually reasonable power has to be transmitted. Okay, so when there is a negative difference, there is a tight fit, and due to this, the power can be transmitted. Okay, so all of the above will be correct. Okay, these all actually corresponds to the interference fit. Okay, so, so all of the above will be correct answer. Right now we're going for what are the type of interference fits. You can refer the slides also to get what are the type of different speeds. So both will flash in blue. Okay. So shrink is again a medium force tight to the tight to it must become that part. Basically here we are mentioning tight means is closely going to interference. Medium force is again against shrink also. So it is actually against clearance type. So these all are actually a part of interference. Okay, so all of the will be correct answer. What is two in place of route never going for transition pit. Okay, so if you go to slides, it may be either clearance put or interference put depending on actual value. Okay, so it is actually looking for transition pit. Okay, compress between clearance and pit. So it's actually the same part. So it's actually correct answer. Applicable where accurate location is important but either a small amount of clearance or interference permissible. Okay, so small amount of clearance and interference is permissible. Okay, so again, this is again correct option. Okay, so all of the above will be a correct option. Okay, we are also getting accurate location also and small clearance also. Okay, so for that we can go for transition field. Okay, so all of the options here are correct options. So all of the above is the correct option. So 32 question. What are the types of transition field now? So can you refer the slides also for that? If you go through the slides, okay, so push fit again this is as it is between clearance and interference fit. Okay, so push fit, force fit, and wrinkle fit all can be used. So okay, as it is different between clearance and your interference. Okay, so it is between both of these. So these things can be applicable. Okay, so actually means this is actually going to transition to part. Okay, so all of the okay will be correct answer. So it is actually slides basically. You can go through. You can get like the idea behind what question is through assignment, and you can get general idea about how you can solve it. Okay, so these are some of the insights that I can give to you. Okay, so based on what you can judge the problems in the assignments. So that is the main part because we are here to enable you to solve the assignments. Okay, because you can see there is no only this live session. So what you can do is just to try to make it more good for your assignments. Okay, so you can solve assignment properly as there is no one being present here means you know about the lectures or about the part taught in during these sessions of YouTube. Okay, so you know this part and considering that you know all these and actually focusing for assignment part you can get more and more marks on assignment and also in your exam exam. Okay, so that's how these are actually planned. You may even see that all of the most of the answer all of the above, but here the actually concept is to give you the thought process that okay, so this is the thought process that you have, these are the parts, so you can if you see the transition fit, okay, so this you must be connected to this part. Okay, so if you in the exams you can recall okay this part is there. Okay, so this is the correct option. Okay, so for that we are making the paths for your brain. Okay, to get simple answers, fast answers for you. You get a roadmap to you. Okay, simply that's why the question are asking like that part. Okay, so if they may ask anything from this part, okay, in this you can if there is any part they can ask, you can answer from this part. Okay, in your exam or even in your assignment. Okay, that is what how it is actually planned by my side. Okay, okay. You can see I mentioned here all of the correct answers, so this is the correct answer already. So this is 32nd question. While measuring outer diameter on length, mandrel is used. Ensure what? So that is the question we have. Circularity, cylindricity, polarity, concentricity. So what are the things of mandrel here? Is it used for circularity, cylindricity, cohesivity, or concentricity? Cohesivity is it is completely different part. Cylindricity is completely different part. Okay. Circularity is mostly different part. That is not use of mandrel. Okay. Use of mandrel I am asking in length. So you have to be very specific about these answers. Okay. You need to be very specific about these answers because we are focusing on the first focusing on this depth and again mandate. Okay, so you have to first focus on the part which is called your this mandate part, first part. Okay, and this is the second part of the focus on. From that we can answer this problem. Okay, this question. Okay, so if you know why the where mandate is used and how the mandate is used, you definitely get the answer. It is coexcentricity. I told here also is the length, mandrel and the length. So this part doesn't come into picture, that part. Okay, so only this constitution came into picture. Okay, so this case of this mandrel plus length. Okay, so this is the case. So this is the correct answer. This is the question again. The grinding process is intended towards which mechanical property? Okay, you can add here. Okay, here you can add which. It is not very it is can so for safety then you can add here this each part. Okay. You can take your time. Bulk removal, okay. In grinding, do we do bulk method removal? Okay. This is not what to do in grinding. Not at all at all. This bulk material removal is a completely wrong answer for okay for grinding. You only do small material, okay, small material removal. You know the slice of chips. Surface the coating is this is use of a coating in grinding. So no, for grinding there is no use of coating. Coating is completely different manufacturing process. And okay, hardness we don't go for grinding. Okay, for that we actually use the heat treatment. Mostly heat treatment is used for this hardness part. To increase the hardness and again the different part of solution hardening and this part we use for we are actually hardness part. It's like this is different actually result of manufacturing process. There is no way manufacturing to increase the hardness, but we can have your like make material part. Okay, materials part. Okay, and only the surface finish is the correct answer for grinding operations. Okay, so grinding is only used for surface finish part. Okay, so your surface finish is the correct answer for what your grinding. Okay, so this grinding is connected to a surface finish part. Okay, so this is your answer, correct answer. Right now we are going for problems. Okay, you can solve it by own. If you can go through the slides, you can solve it by own. After that, we can solve it. Okay. Okay. For what you want to focus is small division in Golden caliper has this part, number of divisions is, and you have to work on list count. Up to which part? 4 decimal. Okay, as it is. Good. Okay, so see everything. So what they are asking actually. Okay. So for Vernier caliper, how much divisions you have? 50 divisions, and this coincides with 49 divisions of mean scale. Okay, and the least count is 0.05. Okay, so how we can proceed here? For one, this one unit division is equal to what? As it is 1.50. So as it is there, it is mentioned here. No, for one division, what we can do? We have to calculate it. Okay, so 1 into 50 into how many divisions coincide with that main scale? 49. Again, and what what Vernier caliper? The number of division each small division can measure up to 0.005. So we can get a value that can be measured here. Okay, so if you solve it, answer that we get is 4.9 into 10 raised to minus 3 units. So it might be it is that unit, okay, because here mentioned in units. So if we have to find the least count, what we can do? So this what we can do is the maximum that can be measured here. Okay, this is what why we are calculating. This is what the last part you can measure in here. Okay, in this part. So right now what we can do, we to subtract this from this, so we'll get the least count. That this is actually the maximum part of vernier scale, and this is from main scale. Okay, this is for your vernier scale, and this is for your vernier scale, and this part is for caliper scale, main scale. So what we can do, and this is for your vernier scale. So what you can do at this part, you will do means you need to subtract this part from main scale. Okay, so then you can get your least count part. Okay, so maximum this minimum part you can measure. So you need to from maximum part here you have to minimize, subtract this part. So this maximum part is actually maximum part only. So after you subtract it, you will get a least count here. So right now we got this answer. So what we can do, we have your main slide. Means this is your main part. This is from your main this will be from your, so this will be from your main scale. Okay, and this is from your vernier scale. So if you do this part, so what you will get is actually 0. Okay, if you do this part, this is actually maximum on your main scale, and this is on your vernier scale. Okay, this is on vernier scale, this is on main scale. If you subtract this part, this is like what up to can measure on main scale. This is you can measure on, this is maximum on the, because your 49 division actually matching with your 15 part. Okay, so this is actually maximum in the vernier scale. So if you do this, what you will get, your least count. So simple, that's simple it is. Okay, so what is the least count will be 0.0001. So 1 into 10 raised to minus 4 will be your answer. Okay, you can get this part. It is your main scale, this is maximum vernier scale measurement. Okay, so you need to subtract this part to get a least count, that part you can measure. Okay, simple. So this is the maximum measurement that you can measure. This actually means maximum measurement is actually less, means your least count. Up to this part you can measure with the scale. If your value is like 0, 1.8 raised to minus 5, you can't measure here. Only up to this part you can measure. Okay, that is what you are actually saying here. Okay, so this is what, this is your actually least count for main scale, and this is for one division of your vernier scale. This can vernier scale can find you, okay, to this part. So when you are subtracting this part, you get actual least count. Because why you are subtracting? Because you are actually using your 49 division here. 1 into 49 division. You into 49. That's why you can see, you can follow that part also, which is given in the slides, or this part also. But you, as from my experience, I can tell you up to that means the 49th age you score beside means actually it is going to 49 part. Means 49 part you know. Is that distance is traveled already. So from that, how we can get discount is only this part. And this is maximum, minimum from your main scale. This is maximum from one year scale. So the left is actually your discount. So this part you can measure here. That is actually the term that this part has eligibility. It is actually the same concept. Okay. So you can refer either of the part. Okay. So your answer is, as mentioned here, 0.0. Okay. So 3 zeros means 1 into 10 raised to minus 4 will be the correct answer, as I mentioned here. Okay, 3000 to minus 4. If you go for minus 5, you can measure. Okay, this part you can't measure. So only this part you can measure with this vernier scale. Okay, this part up to minus 4. This is what we have mentioned. This is the correct answer. Okay, so this is 35th question. Exactly like the previous one we saw, each small division of main scale of a vernier caliper is 0.075 when the scale contains 75 divisions, and this exactly coincides with 74 division of main scale. The least count of the vernier caliper unit is. So exactly like previous question we will solve. We will solve exactly like previous one. Okay. You can take your time to solve. Okay. After that, I will solve this question. Okay. This is exactly like same. This one. Okay. Okay. So to get the value on the 1 year scale, what we will do, you know, it is actually what the number of divisions on 1 year scale? 75. So 1 by 75 into each cell coincides 74, which is actually, and what for on mean scale, what the value it signifies? 0.075. So okay, so what will be the answer over here? It is 0.074. Okay, what is actually means your maximum or Vernier scale. Okay, and your small count on your main scale is 0.075. So if we have to calculate the least count, what we will do here? Exactly like the previous part, your least count will be this from your main scale minus max from your vernier scale. From that you get, you know this fact why I am taking max, because if you see 75 that will go from this answer at this max from vernier scale. So why I consider this max? Because the 75 division coincides there. That's why I will going to consider the max on vernier scale, not on main scale. It is max on vernier scale, and this is a discount on minimum on the main scale. On main scale. Okay, so from that, the difference that you got will be the least count that you can measure on the your with that instrument, okay, with that vernier calipers. Okay, so this is a minimum on the mean scale and the maximum on the vernier scale. From that, if you subtract both, you get least count. It is fairly simple. Okay, because as 74 division is getting, so your maximum division of your vernier scale. Okay, so this will be vernier maximum on vernier, and it will be medium on the main scale. So you will get this part. Okay, so this will be your vernier scale. So you will use this part. This is 75 part. On your main scale, this will be this different your main scale also. And it starts from some, as it is the 75 major units. It is, you just need to see those count. Okay, so this maximum, this difference, you are using your maximum of your
vernier scale, and this is your first on your, it's not like that big, it's like this big. This is your first division on your main scale, and this is your vernier scale. Okay, so this is how it is going. So this gap will be your discount. This is what you are calculating here by subtraction. So your maximum here and your minimum this. Okay, so this difference that you have here, okay, this difference here. This is your this. What is the this part I mentioned here? This difference. This difference you have here, this part. This difference is actually a discount that can be there. This is what the formulation what we are doing here is used. So that's what you need to submit here. Is subtract here. So this from this you get discount part. Okay, so this is how you can work. So if you submit it or subtract this 0.01 millimeters. So this will be your answer. Which is 0.01. This is your answer, which is this. So it is not millimeter, it is just units. Okay, so as you are mentioning units here, I am not question millimeter or anything. So here it will be 0.02 units. Okay, this should be your answer. Okay.
This is a 36th question.
So let me solve this question for you. If you tried this, it's okay. So let us solve. So what they have mentioning here, it is possible to drill 200 millimeter of nominal hole to an accuracy of 28 plus or minus 0.03. Okay, so it is mentioned. So for hole, here we are calculating. So what we do for hole? So it is for hole. So what is that? 28.03. Okay. What is your next value? That is minimum value 27.97. Okay, so what you do? Just subtract that part. Okay, if you know the how to do this part. Okay, so when you do this part, this is for hole. This will be your answer. Is 97. Okay, so what is actually mean? So the to get the clearance allowance that we have. So what is the allowance that we have here? 0.02. And what is the maximum clearance should not be more than this. Okay, so machine to be clearance 50 above or such that allowance should be 0.02. So what is how you can do? This is dimension for hole. So this is your, it's considered this 27.97 as a whole dimension, and this is your slightly high, which is 28.03 dimension. So what you have, you to have the hole means you must have allowance. So you have to design your upper shaft, upper limit of the shaft. How you can design upper limit of the shaft? So it must be as it is minimum. So 20, you can see, you can get this part. You have to insert this shaft inside this part. So this is your shaft. So you will insert this shaft in this part. So it is a different color. Okay, so we'll do different color here. So what we are actually working here. So this is your shaft. So we need to decide what is the maximum level, maximum diameter of the shaft, and what allowance you should provide here. 0.02 is the allowance that you must have. Okay, so by subtracting this, you can get subtracting this value from your whole value. You can get this part. Okay, you can in this figure you can easily get this part. Okay, so what you do, just subtract here from figure, you can easily understand. Okay, as you have to have clearance speed. So what is the answer for your upper limit of the shaft? Is 27.95. Okay, we can, it's very easy. Right now, what you need to find lower limit of your shaft. So how you can get a lower limit of your shaft? Need lower limit of shaft now. Okay, so how you can get lower limit of your shaft now, and what maximum that can be possible? Consider your hole is big. This is your big. This is your hole. This is manufacturer. So maximum allowance, that maximum clearance, that should not be more than this. So this should not be more than 0.1. So okay, from this figure again you can understand what we need to do. Right now we have to subtract from the bigger circle. But what? This part, not this part. Okay, should not be. Okay, so what we will do right now here, 28.03 minus 0.1, which is equal to 28 is 27.93. Okay, and what they ask here, tolerance. So upper minus lower. So tolerance for shaft will be simply 27.95 minus 27.93, which is equal to 0.02 millimeters. Yeah, everything is millimeters. So this will be your answer. Okay, and we have mentioned here. Okay, you know this part. Okay, from this diagram you can get this part. Okay, so this you know from this diagram you definitely get this part. Okay, this is your shaft. This is your hole. This is your hole. Okay, so what we did here, you have some lower limit of your shaft. Okay, so if it is at a lower limit, so we find the maximum part of your shaft. Okay, because it must be there. That allowance must be there. That clearance must be there with you. So what that part should be? It is 0.02. Okay, so we need to subtract that to get your shaft. If your hole is this size, exact means bigger size, so it must not be what they have mentioned there. It must not be. Okay, so it must not be 0.1, more than 0.1. So what we can do? We can just subtract this 0.1 to get this answer, because we don't want more than that. We want only up to that. Okay, so your this distance will be 0.1 as they are mentioned, and if you get tolerance, so this will be a tolerance. Okay, so between the this is this is will be a maximum for shaft. This is minimum for shaft. Okay, so this is maximum for shaft, max for shaft, min for shaft. Okay, on exactly this basis you can solve the next problem. This is your answer. This is your next problem. Exactly like same you can solve. So what do you have? What do you have here? Just you have sides as A of what? Hole. You need to put what? Shaft inside it. That is the point. But what a hole such that allowance should be means what is the must part here? If though it is like it is smaller, if it manufactures slightly smaller part here, but your hole must have this as your allowance between a shaft and hole must be this. Okay, and in case it is got bigger, then it should not be greater than, because it is huge, it should not be greater than 0.01. Okay, so what we will find? You will find this minimum part and the subtract part exactly like previous one. Okay, so I told you this example, this part how it actually is, because you need what clearance fit here. So there must be a gap, and what gap? You must have this gap. But if it is got bigger, so as it is a problem, so maybe means in manufacturing you have problems. So if there is a fluctuation, it should not be more than this. So you should take all of this. So this part also, this part also. So exactly like previous problem, you have to solve it. Okay. You can take your time, own time to solve. Okay. Okay, so if you got by same ideology, what will be your answer here? So it will be for whole 8.002, and again your lower part is this. And right now what you must have, it is 0.003. It is a must part. Yeah. Okay. So from that what you get? Your upper of shaft. Okay, as you told from this part. Okay, so you know this part, upper of shaft you want. This is your hole now, and upper of shaft. Okay, this must be 0.003. So what you got, what upper of shaft you got? 7.995. And right now lower of shaft, which should not be. So this is a shaft, and this should not be. This should not be 0.037. Okay, so it must be in this part. Okay, should not be greater than this part. Okay, so it must be less than this part. So how we can calculate here? Right now we have big part. So as it is not this, it is considered, you have to consider the max part. Okay, so big part you have to consider here. So it will be, and your answer will be that allowance you have to get. Okay, this tolerance, last tolerance of the shaft will be this minus this part. Okay, so you can easily get, is equal to 0.0. So this is your answer. So exactly on this basis, solve this problem. It is slightly bigger problem. Okay, and exactly like that we can solve this problem. It is slightly bigger problem. Okay. So what we have here for shaft now, calculated tolerance, exactly same problem we have. Start with hole. What we have for hole here, upper part and then lower part. Okay, so what allowable, so allowance that should above hole, okay, should be, so consider that you have minimum hole, and what do you require. Okay, so to fix that repeater, okay. So your BD, this is your minimum hole, this part minimum hole, and the burst clearance width that you have is, this is your shaft, is 1.5. Okay, so this is your minimum, and this you must have. You have to subtract 1.5 from this part. Okay, so what you get here, 85.7. Okay, this will be your answer. Just write correctly, 85.7. This will be the answer. And right now, that part is for your, this is for your which part? Upper part. Okay, you know, upper of shaft will be 85 point. And what is the lower of shaft? What this, what lower of shaft means what? Right now, what you have your maximum hole, and this should not be 2.8. So it must be 2.8 or is less than 2.8. Okay, so this should not be more than. Okay, see here what they have mentioned. You can if you not understand, please also click on it. Should not be more than. This is important part here. Okay, should not be more than what they have mentioned here, 2.8. So right now this is a shaft, and this should not be more than 2.8, that is mentioned here. So you have your bigger hole now. I should, because it should not be, it should not be greater than 2.2. So you have to subtract here in that way. Okay, so what you can get, you get 8.08 minus 2.8. So what is the answer for your lower lower limit of shaft? Okay, the lower limit of shaft. So it will be 85.28. Yeah. So for your upper limit, it is, so what is your right now tolerance for shaft? It will be your upper minus lower. Okay, so it will be 85.7 minus 85.28. It will be 0.42 millimeters. This will be your answer. Okay, you can check this answer. So this will be your answer. Okay, so this will be your answer. I hope you saw this answer. It's great this part. Okay, so here we are concluding our problem solving and doubt clearing session number 10. Okay, so you need to submit your assignment by this Wednesday. Okay, so submit your assignment by this Wednesday, and good night. Okay, thank you for your attention.